Sequences. Do not forget to subscribe, and if you have any question, feel free to ask or suggest anything. Sequence is a list of numbers that are in a particular order. Look at the following sequences. Each number in a sequence is called term. So, in the first sequence, 1 is the first term. And the first term is written as a sub 1. 4 is the second term. And the second term is written as a sub 2. 9 is the third term. And the third term is written as a sub 3. And so on. In the second sequence, 2 is the first term. 4 is the second term. 6 is the third term. And so on. In general, a generic term in a sequence we called a sub n, or the nth term. A sub n is any term in the sequence. A sub n is read as the nth term. N shows us the position number of each term. It's very important to be able to recognize patterns in sequence, because if we recognize patterns, we can write a formula to describe the sequence and find missing terms in a sequence. Let's recognize the pattern in the first sequence. We can see that the first term is 1, and 1 is the same as 1 squared. The second term is 4, and 4 is the same as 2 squared. The third term is 9, and 9 is the same as 3 squared. The fourth term is 16, and 16 is the same as 4 squared. So it looks like the nth term is n squared. Let's recognize the pattern in the second sequence. We can see that the first term is 2, and 2 is the same as 2 times 1. The second term is 4, and 4 is the same as 2 times 2. The third term is 6, and 6 is the same as 2 times 3. The fourth term is 8, and 8 is the same as 2 times 4. So it looks like the nth term is 2 times n. Let's recognize the pattern in the third sequence. We can see that the first term is 3, and 3 is the same as 2 times 1 plus 1. The second term is 5, and 5 is the same as 2 times 2 plus 1. The third term is 7, and 7 is the same as 2 times 3 plus 1. The fourth term is 9, and 9 is the same as 2 times 4 plus 1. So it looks like the nth term is 2 times n plus 1. Let's see how it works. Describe the following number patterns and write down the 10th term of each one. Let's recognize the pattern in the first sequence. We can see that the first term is 1, and 1 is the same as 1 cubed. The second term is 8, and 8 is the same as 2 cubed. The third term is 27, and 27 is the same as 3 cubed. The fourth term is 64, and 64 is the same as 4 cubed. So it looks like the nth term is n cubed. Let's recognize the pattern in the second sequence. We can see that the first term is 2, and 2 is the same as 1 times 2. The second term is 6, and 6 is the same as 2 times 3. The third term is 12, and 12 is the same as 3 times 4. The fourth term is 20, and 20 is the same as 4 times 5. We should notice that in all the products, the first number is the term number and the second number is the term number plus 1. So it looks like the nth term is n times n plus 1. Now we have the general term formula for each sequence. Then we can find the 10th term of each one. We replace n with 10 in each one and perform the calculations. Consider the sequence. Now let's take the sum. The sum of the terms of the sequence is called series. A series is the sum of the terms of a sequence and is denoted by S sub n. S sub n represents the sum of the first n terms of a series. For example, S sub 2 is the sum of the first two terms. S sub 3 is the sum of the first three terms. S sub 5 is the sum of the first five terms. A shorter way of writing a series is using the sigma notation. The Greek capital letter sigma is used to represent the sum. Here the symbol sigma is the Greek capital letter sigma corresponding to our letter S and refers to the initial letter of the word sum. In short, the Greek capital letter sigma is used to indicate a sum. This series can be represented by sigma notation. In front of the letter sigma, we write the general term formula. Usually, we want to start at the first term, so n equals 1, and we write that at the bottom of the summation sign. We want to stop for any value of n, and we write that at the top of the summation sign. This expression is read as the sum of all the terms a sub n as n goes from 1 to n. See this example. We can represent the sum of three first terms using the sigma notation. This expression is read as the sum of all the terms a sub n from n equals 1 to n equals 3, or the sum of all a sub n as n goes from 1 to 3. Let's see how it works. Consider the sequence. Write down an expression for S sub 5. We have to write an expression for the sum of the first five terms. Write an expression for the previous series using sigma notation. To write a series using sigma notation, we need the general term formula. But in this sequence, the general term formula is n squared. This expression means add up the values n squared from n equals 1 to n equals 5. To generate the terms of a series given in sigma notation, successively replace the index of summation with consecutive integers from the first value to the last value of the index. In short, to generate the terms of this series, replace n by 1, 2, 3, 4, 5. Evaluate each series. The first series means add up the values 3 times n plus 1 from n equals 1 to n equals 3. To generate the terms of this series, substitute consecutive integers beginning with n equals 1 and ending with n equals 3. The second series means add up the values 2 raised to the power of n from n equals 1 to n equals 6. To generate the terms of this series, substitute consecutive integers beginning with n equals 1 and ending with n equals 6.